Today's the 10th. Welcome. I'm glad. I think, are you all here today? I didn't take roll. Let me pause. I got to pause my recording real quick. That would be right. It's the 10th. And today, get this out of the way so that we'll have a couple work days at least. I'll try to give you as much work time as I can today. I never know how long this lesson is going to take. It scares some people. So just luck of the draw, I guess. So we today are converting standard to vertex. And as you learned yesterday, vertex form is super palatable. Like, I mean, I know that you don't walk away from it and go, I liked that, but you did walk away from it like it was easy. And it's way more fun. That's not the right word. It's way more peaceful to graph functions when they're in that nice vertex form than it is when they're in the annoying standard form. So that's really the inspiration for all Algebra 2 teachers showing their students how to do this. So today, again, the mission is we're going to take the ugly standard form ones and we're going to convert them into the pretty little vertex ones. And that's really probably all we'll do for at least a couple of days. And today I'm going to leave out the ones that have fractions in the actual problem. That's not to say that we won't need them to do the problem, but the problems themselves won't have fractions until next week. All right. So let's take a look. This is standard form. We agree. So if I asked you to graph it, you would do negative b over 2a, you'd find some number, you'd plug it back in, you'd get the y. You know the drill. You've practiced this before. Our mission today is to make it look like the problems yesterday. So I'm just going to give you a super easy, like, make sure you follow these steps kind of deal. Are you ready? Good to go? All right. So the first thing we're going to do is we're going to take the plus 1 and we're going to move it off to the side. We're going to take and leave the x squared and the plus 10x alone, and then we're going to leave, you've seen me do this many times before, we're going to leave an awkward void, and we're just going to simply slide the plus 1 off to the side. There will be some parentheses in a little bit. You'll see. So what we're going to do now is complete the square. And as you noticed from yesterday's, the vertex form is a square, right? Every problem had like x minus 4 squared, x plus 1 squared. So what I want to do is right here, what I'm underlining in red, I want to be a square. And had we not already learned how to do this, then I'd be like, wow, they don't know what to do. What's half of 10? What's 5 squared? So I'm going to add 25. Now, this might weird you out the first time or 3, but you'll get over it. I'm actually going to now turn around and subtract 25 at the end. And that, by definition, is just nuts. Like, why would anyone in their right mind just add 25, only then to turn around and erase any trace of what they did? Well, if you think about it, we're doing it on the same side of the equal sign. We're not doing it like with the other completing the squares. We would add 25 to one side and then add 25 similarly to the other side. That's how you behave when you're hitting opposite sides of an equal sign. But here, you're hitting it twice on the same side. You cannot mess with the left. We talked about this yesterday. Someone asked a question about, can I divide everything? Or no, you can't mess up the y. The y equals is what makes it a function. And so having said that, the plus 25, we have a purpose. The minus 25, I use the analogy of he's the guy that comes behind and basically erases the footprints. So it looks like the 25 was never there. You have to agree with me, I won't let you off the hook until you do, that the net result of the red plus 25 and the minus 25 is nothing. Do we agree? So mathematically, we've done nothing. We've done no harm. But the plus 25, the first one, serves the purpose of creating a square, which, when factored, factors into x plus 5 squared. And then 1 minus 25 is negative 24. And just like that, the problem's over. It just happens like in an instant. You have now converted a standard form equation into a vertex form equation. And if I asked you now, based on the bottom answer, where would the vertex be? If you were here yesterday, you know this. Where's the vertex of that parabola? Negative 5, negative 24. That's it. It doesn't look like it's going to happen that fast. Like, I think the first time you do this, when you're around in here someplace, you're in this step and you're thinking to yourself, like, what is going on? And then it just poof pops out, problem's over, you're done. Yeah, we're not gonna be graphing today. We're just gonna be converting to Vertex and then naming what the Vertex would be. I don't disagree with what you're saying, other than that last thing you said, because that was really mean and hurtful when I read your lips. But the first part thing that you said, I agree with. Like, yeah, that would suck to graph. You agree with that, but you don't have to graph. So yeah, that other one, you should probably apologize for that later. Yeah. Because it makes these equal 0. So the x coordinate of the vertex is what makes the square part equal 0. It's where it zeroes out, centers out. So -5 is the zeroing point for x plus 5. Good. You okay there, Bree? Couldn't agree more. Let's go again. Oh, we got several. Don't worry. There's 2 stages of worseness after this, one of which I'll expose you to today, and then the fraction one, which isn't actually all that bad, I'll expose you to at a later date. So, Jared and you guys who are leaving, make sure you pick up the video right from here because it's about to get a little nutty on the next one, okay? Thanks, guys. See you. Have fun. So you shouldn't have any issue. This goes real quick with these easy ones. So we're going to boot the 8 off to the side. So I'm going to say +8. Just go ahead and scoot on over there. And then follow this completing the square algorithm. What's half of 2? What's 1 squared? So I'm going to add 1. And what am I going to do to erase his footprints? I'm going to subtract 1. That way there, the net result is nothing. And I have y equals. Done. And the vertex of that parabola would be at what point? Good. So I think I can bypass a couple. I had, we have to do one with fractions. My bad. I forgot about that. That's just a typical Ahern thing to do, is just to move on, and I'm not doing it today. I'm not going to mess this up. So here we are. And right away, you see the issue. I've already moved the +9 off to the side and left room for the completing the square step. I'm going to be okay if you want to use decimals today. I know a lot of you guys really got comfortable using the fractions, but I'm okay with decimals just because of the nature of these decimals are always predictably 0.25s and 0.5. So like they're really nice, friendly decimals. So if that's how you like to do your things, then feel free. You're green lighted for that because it's much more calculator friendly. So anyways, what's half of 9? 4.5. And what is 4.5 squared? Careful. It's not as easy as you think. 4.5 squared is a little more complex than the human brain likes to think. So yeah, you will probably want to calculate that. 4.5 squared. Unless you can do 45 times 45 in your head and move the decimal. But did you say 20.25? Okay. Yeah, or 81/4. And I can do this problem both ways. And so if you take 9/2 and square it the way we're used to, yeah, we get 81/4. But if you want to try out today just working with decimals, then we can do plus 20.25. I'm okay with this because of just the way these decimals are. There's no 0.83s and 0.76 repeating kind of stuff like that. These are nice. And then what do we do to erase his footprint? Minus 20.25. Good. So again, at this point, I've done literally nothing to upset the math gods. I've added something and offset it with an equal subtraction. Everything's fine. And then when I go to write out my answer, I'm going to have y equals x plus what? Yeah, and again, you can do 9/2 or you can do 4.5. Either one is equivalent. So just to kind of in keeping with the decimal theme, since this isn't normally how I roll, I'll just put 4.5 in here. We'll square it, and then we're going to put minus, what is that? 11.25. Done. And I kind of green lighted myself on this morning when I looked at this, because this is the way in Delta Math, if you know how if you miss one, how it gives you an explanation, their explanations use decimals. So I wanted you to be aware like that there's no hijinks or shenanigans going on. It's okay. They mean the same thing. And if you got super comfy with your fractions, your answer would be y equals x plus 9 halves squared minus 11 and 1/4, which would be like 45 fourths, right? So if you're comfy with that way, go that way. Like the program will take either one, of course, as long as they're right, you know. So you comfy with the decimals? All right, now we have to get to the part of this that is potentially a little bit weird. Let's see. And I'm going to go ahead and move the plus 68 off to the side. I'll quit writing it there just so, because I mean, then we have to just turn around and move the darn thing anyway. So let's boot it off to the side. So instinctively, what do you think you want to do? Divide. What'd you say? Is that what you said too? Good. We should all be thinking divide by 4. So you've learned well. No, I wasn't sure. They said the same thing, and I'm really glad about that. So good instincts. I was worried some of you might try to take half of 32 and square it, and that was what I wanted to try to get in the way of there. Don't do that. Remember, we learned with completing the square that the process needs to be like, basically we need to clear a pathway to make this doable or workable or simpler. And so what we want to do now is divide by 4. But I want to show you something about this. I'm going to take the 4 and I'm going to divide it out of these two terms, but I'm going to leave the 68 alone. You can totally do that. You can just, because I'm not really dividing as the F word, I'm factoring. Yeah, the other F word there, Gavin. So right. Sorry, Sienna. So again, we're dividing, but we're not breaking any laws here because the 4 isn't dividing itself into oblivion. It's still there. It's like, hey, I'm still here. You just basically pulled me out of the 4x squared and out of the 32x. I'm still here. So no math gods are upset. And now what we're going to do is we're going to complete the square. Inside the parentheses, what's half of 8? What's 4 squared? Good. So I'm going to add 16. And how do I erase his footprints? Exactly. You subtract 64. Good. Yeah. And no, I did not just have a stroke. So that every time it happens, every year, every class, people look at me like I've got two heads. Like, why did I subtract 64? Yeah, I'm going to point to a number right here, and you're going to think I'm crazy. And you know that I don't care. If I worried about that, I wouldn't behave the way I do. I'm going to point to a number right there and tell you that is a 64. And I know you, what? Yes, it is. Because the 16 is embedded in a set of parentheses that is attacked by a 4 on the outside. So the net value of putting a 16 in there is actually adding 64 because he gets weighted up by the 4 out front. So when you do the footprint eraser step, you don't just always subtract the number that you wrote. You have to be aware if he's in parentheses that he's not what he seems to be, right? So subtracting 64 erases the footprints in this case. And if you understand that, then the rest is, again, just it's gonna pop right out. Y equals 4 times what? Squared plus 4, done. Say it again, buddy. Oh, the vertex? Yeah, negative 4, 4. Yep. Good. Let's try one with a negative out front. We're about to find out. So just train yourself, because you're going to be doing this for a couple days now. Train yourself to just make it look like this. Get your quadratic term and your linear term packaged together, and then boot your constant term an inch or two off to the right. Leave yourself room. And what are we going to pull out of those first two? The negative 3. So I'm going to pull out a negative 3. I will always pull out whatever is attached to x squared. Whatever I need to do to make him just say x squared. What's that going to leave me with? X squared minus 10x I know. I just keep doing this to you, but it's good to learn. That's I think there's a certain way to learn where like you actively are engaged in watching someone and you think they made a mistake, and there's good learning to be had there. Why did I switch that plus 30 to a minus 10? Because I divided by a negative. The number that I pulled out was a negative. And if you ever want to know, if you think I'm talking crazy, you can verify it by just some redistribution. Like what's negative 3 times that? That worked. What's negative 3 times that? Ah, that worked. So when you pull a negative, you've got to switch the signs, of course. Make sense? This number that I'm about to write in this blank will always be a plus. Let's be perfectly clear about that. Because that's when you complete a square, by nature, you're adding in something squared, which will be positive. And that's going to be half of negative 10 is negative 5 squared is indeed plus 25. And I'm going to erase the footprints of that plus 25 by doing what? Nope. I'm going to add 75. I'm just toying with you at this point, right? But do you see why I added 75? What is this shenanigans? Like I thought we had to subtract to erase the footprints. Well, if I point to this number, yes, if I point to this number and ask you, what really is that number? What would you say? That's really a negative 75 because it's multiplied eventually by this negative 3, giving it an actual value of minus 75, which the opposite of is plus 75. So will the footprint eraser always be subtraction? No. It'll always be whatever it has to be to kill or erase the square completer. Got it? Righto. And then from there, it just, again, it happens quickly. You have y equals negative 3 times what? X minus 5. Done. It cleans up nicely. It's so fun to watch it like go from that messy state to just boom, that beautiful, delicious little vertex form. Love that. It is delicious, isn't it? I put this one on my note card because I wasn't really sure. I didn't think it would freak you out, but the jury was still out, so I thought better write it down. I'm sorry to ask dumb questions, but what's weird about it? There's no constant, right? So so you could put it as a 0 if you want. Yeah, if you really wanted to. Or you could just not put anything at all. The space I need to complete the square is conveniently already there. So I can really just proceed. What's half of negative 12? What's negative 6 squared? So I'm going to add 36. And I don't really have to go very far to erase his footprints. I'll just go right next to him and put a minus 36. Because there's really no one for the minus 36 to join with, because like we heard, it would have been a 0. What's the point, right? So then when we've completed the square, so this that I'm underlining is now, remember, that's called a square, right? And what does it factor into? Done. Six and negative 36. Once you get it into vertex form, your coordinates of your vertex will always be the opposite of what I have in yellow and the identical of what I have in green. Opposite yellow, normal green. What do you guys think? Not bad? Gavin's ready to rock and roll. Let's do one more. Yeah, is that ugly? Sorry, I thought that's a negative 150. Maybe not my best 5 of all time. What are we going to do first? And remember, when we talk about division, I'm going to underline this for you. We're only dividing the quadratic and linear terms. Leave the constant alone. He doesn't need to be a part of this. It'll make you it'll blow your if you try to do that. So leave him alone. And if I pull out -4, what's left of my terms? Mm-mm. Tienes que dividir los dos números por -4. What's half of -12? -6 squared. It is. So I'm going to add 36. And again, that 36 is he's in disguise, right? He's not really a 36. What is he? He's really a -1 faux de faux because he's multiplied really by that -4 that's lurking out front. So if you think about it, these two guys connected by the blue arrow, they're in cahoots together. And that -4 multiplies to reveal the true identity of the 36. And he's like, you're actually a -144. So to offset me, you had better. I forgot to bring down my -150. That's my bad. But yes, to offset him, we are going to add 144. You do whatever you have to do the opposite of what you did. We got to make it look like we were never there. We haven't, it's fun to think like we've literally not changed anything about the equation. Structurally, it's still identical. It still means the exact same thing. It just looks the way we want it to look. That's pretty cool. So what's our final answer? Jackpot. Where would the vertex be? Right 6, down 6. You got it. And tell me about this graph structurally. If I asked you to graph it, would it open up or down? Open down, skinny or fat? Super skinny, guys. Remember that the bigger numbers, like the further the numbers get, the bigger the absolute value the numbers get, the stronger the pull. So like on this graph, if you go out 1, you go down 4. If you go out 2, you'd go down 16. You go down out 3, you're down 36. So that's a super skinny graph. Remember, bigger numbers make skinnier, smaller fractions make fatties. Do you guys have any questions? All right, I'm gonna pop up an assignment for you in about 1 minute and 39 seconds. I don't know, can you? Sure.